Okay, we're on page 4 of the notes, section 7.3, fractional or rational exponents. We have here a variable base of x and then a fractional exponent of m over n. If n is a positive integer, then x raised to the fractional exponent m over n is equal to the denominator of your fractional exponent is the root. So it is equal to the nth root of x raised to the m power. Okay, so the denominator is the root. The denominator of your fractional exponent is the root, and then the numerator is the power. That's how we're going to interpret fractional exponents. There is this other way here, okay, it's still n is the root and x is raised to the m. So the numerator can be inside underneath the radical, or it could be outside. But for our purposes, we're going to be writing that this way. If n, which is also called the index of the radical, is an even number, the base x cannot be negative. However, if n is an odd number, the base x can be negative. That's because if n is even, an imaginary number would result. For example, we have -8 raised to the fractional exponent 1/3. That means the 3 here, the denominator of our fractional exponent, is the root. So we're looking for the cube root of -8 raised to the first power, although that isn't written. Well, what's the cube root of -8? It's -2, which is a real number. However, -16 raised to the 1/2, again, the denominator of our fractional exponent is the root, so that means the square root, the second root, or the square root of -16, which would be 4i, which is, as we know, an imaginary number. We're going to follow these steps in evaluating an expression containing a fractional exponent. We're going to rewrite the expression in radical form, evaluate the root, and then evaluate the power. Now, before we get started, let's use the space over here to the right and just write down some powers, like 2 to the second we know is 4. 2 to the third, recall, is 8. 2 to the fourth is 16. 2 to the fifth is 32. Some powers of 3. 3 to the second, or 3 squared, is 9. 3 to the third, or 3 cubed, is 27. And 3 to the fourth is 81. Powers of 4. 4 squared is 16. 4 to the third is 64. And let's just also write in 5 squared and 5 to the third. 5 squared is 25, and 5 to the third is 125. All right, you want to kind of be familiar with these. If you see 81, you want to realize that, well, that's equivalent to the cube root of 81 would be 4. All right, so going back, we're going to rewrite the expression in radical form, evaluate the root, and evaluate the power. So we want to evaluate these or simplify these without using a calculator. All right, so number 1, we have 25 raised to the fractional exponent of 1/2. Well, again, the denominator is the root. So this is going to be the square root, and we need not write the 2. would be the square root of 25 raised to the first power. Again, it's not necessary that we write the power 1. What is the square root of 25? Well, we know that is a perfect square. Its square root is 5. Number 2, 27x raised to the 1/3 power. Okay, so the denominator here is the root, so that means the cube root of 27x raised to the first power. 27 is a perfect cube. Remember how we used to simplify these? We would circle the things that were perfect. Out comes its cube root, which is 3, and the rest stayed. Cube root of x stays. And that's our answer. Number 3. We have 16x raised to the negative 1/2. Okay, well, let's take care of the negative first. Take our base, 16x, and write it as 1 over 16x raised to the positive 1/2. So 1 over. Again, the denominator of a fractional exponent is the root. So this means 1 over the square root of 16x. That's a 2 there. Again, it's not necessary if we're talking about square root. You don't have to write the index 2. 16 is a perfect square. Out comes its square root, which is 4, and the square root of x stays. But we can't stop there. We have to rationalize that denominator. So the only thing that's not rational is the square root of x. The 4 is fine, so we're going to multiply by 1 in the form of square root of x over square root of x. And then in doing so, we get for a numerator square root of x over 4. Square root of x times square root of x is going to leave us with just x. And that's complete. Number 4, 125 to the negative 1/3. Again, take care of this negative first. We would write it as 1 over 125 to the positive 1/3. One over, again, the denominator is the root. That would be the cube root of 125. And 125 is a perfect cube. Its cube root is, remember what we wrote down up here? Cube root of 125 is 5. So that's 1 over 5. Number 5. Negative 125 raised to the fractional exponent of 1/3. Again, the denominator is the root. So we would write this as the cube root of negative 125 raised to the first power, but again we omit that. That's a perfect cube. The cube root of negative 125 is negative 5. Number 6. 81 raised to the fractional exponent negative 1/4. Take care of the negative first. We'll rewrite it as 1 over 81 to the positive 1/4. The denominator of our fractional exponent is our root, so that means the 4th root of 81. So that's 1 over the 4th root of 81. And what is the 4th root of 81? That is perfect. If you need to, look up above. 3 to the 4th is 81, so the 4th root of 81 is 3. So that'd be 1 over 3. Number 7. 27x raised to the 2/3. Again, for our fractional exponent, the denominator is the root. So this would be the cube root of 27x, and now we're going to square that. Well, 27 is a perfect cube. Its cube root is 3. So 3 comes out, the cube root of x stays. And then all this is raised to the second power. So we have 3 times the cube root of x raised to the second. So we have this product raised to an exponent of 2. So we're going to distribute the 2. 3 squared is 9. And the cube root of x squared is just that, the cube root of x. We can put the 2, the square, on the outside, or it's more standard to put it on the inside. So 9 cube root of x squared. Number 8. 16x raised to the exponent, the fractional exponent, 3 over 4. Again, the denominator of our fractional exponent is the root. So this is the 4th root of 16x, and then we'll raise that to the 3rd power. What is the 4th root of 16? If you need to, look up above. 2 to the 4th is 16, so the 4th root of 16 is 2. So this is equal to 2. The 4th root of x stays, and then the whole thing is raised to the 3rd power. And now we distribute. What is 2 to the 3rd? And then the 4th root of x raised to the 3rd. That's 8 4th root of x to the 3rd. Next page. Continuing on with number 9. We have negative 8 raised to the 2/3. Okay. Again, the denominator is the root. So this is the cube root of negative 8 squared. Well, that is a perfect cube. The cube root of negative 8 is negative 2. And now square that, and our end result is positive 4. Number 10. 27x raised to the negative 2/3. Take care of the negative first, right? By writing it as 1 over 27x raised to the positive 2/3. The denominator is the root, so this is going to be equal to 1 over the cube root of 27x squared. The cube root of 27 is 3. So 1 over 3 cube root of x, and then we have to square that whole thing. One over 3 squared is 9, and the cube root of x squared. Well, we cannot leave this radical in the denominator. So if we brought that x squared up to an x to the third, then we could take its cube root. So we're actually multiplying by the cube root of x over the cube root of x. And that would bring us to the cube root of x over 9x. Made that a little large. That's the root. That 3 is the root. Cube root of x over 9x. Next, number 11. We have a fraction, 8/27 raised to the fractional exponent 2/3. Again, with our fractional exponent, the denominator is the root. So this is the cube root of 8/27, and then we're going to square that. Well, these are both perfect cubes. Cube root of 8 is 2, and the cube root of 27 is 3. So we end up with 2/3, and then square it. And that equals 4/9. Number 12. We have 8/27, so we have a fraction, 8/27 raised to the fractional exponent of negative 2/3. Again, when we have a negative exponent, take care of the negative first. Since this is already a fraction to start with, we simply invert the fraction, right? So this is going to become 27/8 raised to the positive 2/3. The denominator is our root. So this is the cube root of the fraction 27/8, and then we would square that result. These are both perfect cubes. Cube root of 27 is 3. The cube root of 8 is 2. So we have 3 halves. Now square to get 9/4. 9/4. Number 13. We have x squared y to the third raised to 2/3. There is more than one way you could do this, but we're going to continue in what we've been following, and that is, right, The denominator of our fractional exponent is our root, so we're going to write this as the cube root of x squared y to the third, and then we're going to square that result. Now the only part that is perfect here, that's a perfect cube root, is y to the third. The cube root of y to the third is y. So y comes out, the cube root of x squared stays, and then we have to square that result. Distributing, I get y squared. Cube root of x squared squared is x to the fourth. Now we find that we can simplify this, right? What part of x to the fourth is a perfect cube? There's a different color for this. We would break x to the fourth down into x to the third times x. Now this is a perfect cube. Out comes its cube root, which is x. And the cube root of x stays. And then don't forget, bring down the y squared. So y squared x, cube root of x. (14) 4x to the 1/2 y raised to the power of 3. We don't have a fractional exponent here. So the only fractional exponent is with the x. So this is a product raised to a power. So let's distribute that power, right? So we're distributing the 3. So this would equal 4 to the third, which is 64. X to the 1/2 times 3 is 3/2. And y to the third. Okay, well, this was 64. And y to the third. Now, the fractional exponent that's associated with the x. Let's write that as, remember, the denominator is the root. So that's the square root of x to the third. And what part of x to the third is a perfect square? X to the second. So we would write x to the third as x to the second times x. Out comes its square root, which is x, and then the square root of x remains. And bring down the 64 y to the third. Okay, our next 3 problems we want to rewrite using irrational exponents, then simplify your answer. Meaning we have the 4th root of x raised to the 6th. Remember, the root or index is your denominator of your fractional exponent. So this would equal x to the 6/4. And now let's just reduce the fraction 6/4, dividing each by 2. So this equals x to the 3/2. Next, we have the square root of 4ab to the 6th. Okay, well that would mean this is each of these terms there would have a denominator, a fractional exponent denominator of 2. So this would equal 4 to the 1/2, a to the 1/2, and b to the 6/2. Well, the square root of 4 is 2. A to the 1/2 would stay, and b to the 6/2 reduces to b to the 3rd. Now, could we have taken square root first? Square root of 4 is 2. Square root of b to the 6th is 3. Got the 2, b to the 3rd, and just left a as a to the 1/2. Yes. Again, there's more than one way you can approach these problems. The next one, we have the cube root of 27x to the 6 y to the 12z. We could actually take cube roots first if we wanted. All right. In fact, let's do that way. If I take cube roots first, these are all perfect cubes. If I take cube roots first, that would give us 3x squared. 12 divided by 3 is 4. And then z remains cube root of z, and I would write that as z to the 1/3. So 3x squared y to the 4th, z to the 1/3. Or take each one, 27 to the 1/3, x to the 6/3, y to the 12/3, and z to the 1/3. Right. And now simplify. That's the cube root of 27 is 3. 6 divided by 3 is 2. 12 divided by 3 is 4. And 1 divided by 3 we leave. Okay, for our last group of problems, we want to evaluate each function for the given value. So number 1, we have f of x equals x to the 3/2 plus x to the 1/2. We want to evaluate f of 9. So we replace our x's with the value of 9. So we have 9 to the 3/2 plus 9 to the 1/2. With our fractional exponent, 9 to the 3/2 means, remember, the denominator is the root, so that's the square root of 9, then raised to the 3rd, plus 9 to the 1/2 is square root of 9. Square root of 9 is 2, and then 2 raised to the 3rd, plus the square root of 9 is 3. Okay, so you corrected me, hopefully. The square root of 9 is 3. That's better. So 3 to the 3rd is 27, plus 3 equals 30. Number 2, we want to evaluate for f of 8. So we're replacing our x's with 8. So we have 4 times 8 to the 2/3 minus 8 to the 4/3. 4 times, well, 8 to the 2/3, the fractional exponent of 2/3 is equivalent to the cube root of 8 squared minus 8 to the 4/3, that's going to be the cube root of 8 raised to the 4th. So 4 times the cube root of 8 is 2, and then 2 squared is 4. The cube root of 8 is 2, and then 2 to the 4th. We'll do that separately. So we have 4 times 4, which is 16, minus 2 to the 4th, which is 16. And 16 minus 16 is 0. Number 3, we want to evaluate f of 9. So we're replacing all our x's with 9. So f of 9 equals 3 times 9, that product raised to the negative 1/3, plus 2 times 9 to the 0. And now only the 9 has the exponent 0 here. So that's 1. So 2 times 1 is 2. All right, going back, 3 times 9, we do it in parentheses here, is 27. So we have 27 to the negative 1/3. Didn't leave much room for this one, so I'm going to go way off to the right-hand side here. Okay, so that was 27 to the negative 1/3 is going to become 1 over 27 to the positive 1/3 plus our 2. And 27 to the 1/3, that's cube root of 27, which is 3. So 1/3 plus 2, or 2 1/3. Or you could write 7/3. All right, so let me just go back here. F of 9 equals 7/3, or you could write 2 1/3. And the last one, number 4. We want to evaluate f of 2. We actually did this one on the previous page of the notes. So could we work out these evaluation problems using the calculator? Yes, we certainly can. All right. From the notes on the other page, this worked out to be 9/2. Okay. Now, yes, you can always take your calculator, all right, and key in alpha y equals to get a fraction. I want 2. I'm replacing x with 2 here, so that's 2 times 2 raised to the 0 power, get out of the exponent, plus 2 raised to the negative 2, arrow out of exponent, arrow down to the denominator, and 2 raised to the negative 1. And press enter. And that's 4.5, which is equivalent to 9/2. And we're done.